I'm delighted you're interested in watching this video. The following content was developed collaboratively with our 3D data software friends. Please share this video. However, it's not okay to modify, copy, publish, create derivative works, license, or offer for sale. If you want to learn more about how to leverage these techniques at your organization, contact us and learn about our Ready, Set, Go, Grow methods to implement 3D digital data to save your organization time and money. Hello, everyone, and thank you for tuning in today. I am Jennifer Herron, CEO and founder of Action Engineering, and we're a company that helps manufacturers to create, use, reuse, and also automate their 3D CAD data in the design, fabrication, and inspection space. We partner with your team to build a resilient future centered on connected, trusted models and an uplifted workforce. Everything we do at Action Engineering leverages practices that are applicable in any CAD and PLM tool suite. We like to call ourselves tool agnostic. Today I'm joined by Daniel Campbell of Capvidia, whose technology helps make this technique we're going to show you possible.
Yeah, thank you, Jennifer. Thanks for the invite. I'm glad to be joining you here today, and I'm looking forward to just having some good conversation about using MBD for PPAP.
Thanks to Capvidia's help, we will describe and demonstrate a technique to balloon your 3D CAD model, create PPAP elements, and then revise the 3D CAD model and PPAP elements automatically. But first, I want to acknowledge the elephant in the room. Inspection is time-consuming and often relies on manual data entry. We've seen PPAP documents that are up to 150 pages in length, and they're often handwritten. There is a better way. Because of this, automotive suppliers are looking for ways to utilize digital solutions to increase their throughput. I'll show you a proven method that uses the powerful combination of MBD and QIF, which is the Quality Information Framework, to communicate both engineering requirements and then feedback results, and we're going to do that all digitally. Our team of MBD experts at Action Engineering will demonstrate how to author digital 3D data that can be consumed automatically while we use Capvidia's software to reduce PPAP time by up to 50%. Let's dive into the solution. If the OEM, or the original equipment manufacturer, uses model-based definition, or MBD, plus QIF to communicate their engineering requirements to their supplier, then they establish a digital feedback loop that captures the engineering requirements alongside the measurement results. For the automotive industry, that communication feedback loop is standardized by the production part approval process, known as PPAP. So in this presentation, we're going to present how we combine MBD and QIF together to communicate both engineering requirements and feedback the results all digitally. And after a little bit of intro on MBD and QIF to ground you in what those terms are and what they can do, we'll demonstrate how MBD annotations are used alongside with model-based product characteristics. And these are smart, machine-readable key characteristics in your product data. And we will see how those model-based product characteristics enable automated data exchange and traceability while also supporting the 7 PPAP elements that I'm showing you on the screen. Now, a mini introduction to model-based definition, or MBD. And whether you're new to MBD or a veteran, you know that every perspective or viewpoint in an enterprise always thinks of MBD slightly differently. So, the CEO thinks this is an instant transition, put in a new technology, write a memo, hey, why aren't we done yet? Marketing often thinks, this is 3D, right? So virtual reality? And at the beginning, engineering is thinking, wow, this is a fantastic utopia without any pesky people on it. But then they realize that the people are pretty challenging and the beach is kind of crowded. Manufacturing thinks, gosh, this is a big mess of change they're going to have to untangle. And quality's thinking, this is a whole bunch of new tools and methods that they have to account for, and they aren't sure how to use it. Supply chain, always juggling fire, so handling different information from different customers, this is just a different torch. Customers, well, they're kind of like CEOs. They're not really aware of the complexity of change and just not sure why it's not done already. And then finally, it's actually a long, winding journey with a lot of switchbacks and moments where you feel like you just haven't made a lot of progress up the hill. However, you can't always tell when you're climbing that mountain when you're going to summit. So my advice to you is just to stick with it. You're going to get to something great and some really great views. Now let me tell you a little bit about QIF, the Quality Information Framework. QIF. It's a framework that is a feature-based and characteristic-centered categorization for metrology data. Using XML, which is semantically linked MBD QIF, is a standard integrated information model for the efficient exchange of data between software and equipment modules for discrete product measurement. Most importantly, it is an official American and ISO adopted standard. This is the QIF donut that describes the framework that exists within QIF today. Think of these as containers for the data. The DMSC relies on software and hardware vendors to create the processes within each of these containers to produce the technologies that QIF enables. Think of Quality Information Framework as a repeatable framework to document, visualize, and analyze 3D data all in one place. MBD plus QIF will do for quality what 3D CAD did for CNC programming in the past decade. So these 7 PPAP elements that you see on the screen are fed by the Bill of Characteristics, which is backed by MBD. And I know there's likely opportunity to tackle the other 14 elements of PPAP, but we've been kind of conservative and are showing the 7 that we think this technology is the most mature for. We wanted to stay focused on the highest value add to PPAP first, but I hope I've got your creative juices flowing, and by the time you're done with this presentation, you will see opportunity to use digital data, and it just unfurls before you. I want to begin the demonstration by grounding you in the current state. So I've broken down the work you do today into some high-level process steps. A drawing is generated for the first step. That drawing is ballooned. A quality planner uses the drawing and balloons to generate an ISR form used in PPAP Elements 9, which is the dimensional results. Then the actual part is measured. Now, often a variance or nonconformance is discovered during the measurement phase, and the inspector must take the variance back to the engineering agency to perform corrective action. Then engineering revises the documentation, and in this case, we're revising a drawing. Then the quality planner must now create a revision to the ISR form. Then the measurement is repeated, and finally, the part is accepted. I've estimated the time it takes on average for each process step to be accomplished. Simple parts may take less time, complex parts may take more time. Some industries may spend more time on each step than others. But to illustrate the time savings, let's assume the average part requires about 8 days to complete this process. Now, let's shift our mindset to thinking about a future state. Just like you did with a drawing, you still need the step to generate MBD. Use your preferred 3D CAD platform in this step. Use CapVidea's MBD Video software to auto-generate the balloons and a table which captures the bill of characteristics. Use CapVidea's MBD software to auto-generate the ISIR form. Measure the actual part. Realize there's a problem with the part and take the problem back to engineering, who performs a corrective action. Engineering revises the documentation, in this case, the source 3D CAD, that is the MBD. then auto-generate a delta ISIR using CapVidea's MBD Videa software. Then the measurement is repeated, and finally, the part is accepted, but in half the time. Daniel, is it fair to say that this is about the level of improvement that people in industry are seeing with this approach?
Yeah, I think so. I mean, I think this can even be conservative. We always recommend to our early implementers that they try to establish kind of a baseline measurement of how much time they're spending right now on their current manual PPAP or FAI process. Because then it gives them a good basis for comparison for when they move to MBD so they can get an idea of their ROI. The time savings from MBD, that's just one aspect of the ROI, but it's a really easy one to measure. And so what we've seen is that usually with the time savings alone for like a MBD PPAP or MBD FAI process, I mean, that's usually enough to basically wow everyone in the organization and make people realize that, yeah, it is worth the move to MBD.
All right, that was the process. Let's dive into the software and I'll show you step by step how this actually works and looks like. This is an average complexity part. This part starts life as a casting and is then post-machined prior to going through the PPAP process.
So here we're looking at the PMI. I mean, this is the data that should be driving our PPAP process downstream. The way things are done now is that, typically all of these requirements exist on a 2D drawing, and you have to have an engineer go through the drawing and read these annotations, interpret them, and then somehow place them into a spreadsheet. This is a lot of work. Obviously, it's a lot of interpretation, and it's all pretty unnecessary. What we're going to see in this workflow is how you should be placing your product requirements as a semantic PMI and then allow that data to simply be reused.
While in Creo, the MBD Videa plugin makes the export to QIF as simple as 2 mouse clicks. Depending on your operations practice, your internal manufacturing or your supplier can use the QIF file to automatically perform the ballooning step. Once the QIF is exported from Creo, then we use MBD Videa to automatically generate the balloons and bill of characteristics. The automated ballooning process eliminates time spent in manual data re-entry. Now that the engineering requirements are digitally identified and a bill of characteristics is made, I can easily and automatically generate an ISIR form using MBD Videa.
Yeah, this ISIR form is really just a sample of what a typical PPAP inspection report might look like. Usually every company is going to have their own look and feel of how it should look, but in essence, I mean, what we can expect is a list of all the characteristics that need to be measured, along with the quote-unquote balloon numbers that correspond to each of those characteristics. And the other thing is that, as we're seeing here, when we do this in the context of an MBD workflow, it's easy to create a sort of MBD-powered Excel spreadsheet like this, which is kind of enhanced. I mean, it includes the model saved views to give a quick snapshot of what each balloon means, and it's all powered by hyperlinks within the Excel and so forth. So, in a way, this is kind of like MBD using Excel.
As an automotive engineer, you need to know how your parts are built. The measurement results you receive from the PPAP process are crucial. In this case, something is wrong with this batch of parts. The quality department must send the reports back to engineering so they can make a change. Because we have digitally encoded characteristics that are semantically connected with the surfaces and features they represent, both engineering and quality are able to access all the data, which empowers their ability to work better together to determine the corrective action or to reconcile nonconformities. In this situation, engineering and quality review the 3D results together and determine how to reconcile the nonconformities seen during first article inspection. Together, they agree on a change and decide to open the tolerance of the slotted holes and document that directly in the MBD. They also decide together that it is acceptable to have an increased tolerance on the radius, and engineering also makes that change. The people that work in engineering and quality now can trust the data because they can visualize the results in 3D, and thereby they have a better understanding of the issues to determine a path forward. In short, they can make data-driven decisions. When all parties are empowered with digital data, their products are much better and higher quality. Oh, and they get built and inspected faster because we have eliminated manual data entry. Bolstered with effective quality data and a digital and fast feedback loop from quality, engineering makes the changes and releases a new revision. What is really powerful about QIF that is powered by MBD Vidya is that once we have a new released revision, we can now release a revised QIF file and then see the delta revisions. So we're not having to redo all the work from the first time. Following good practices when issuing changes as MBD, I automate the comparison of the original design with the changed design.
Yeah, so the general workflow here is that we're comparing the past revision of our model to our current revision, and compare video reveals everything that has changed. And then from there, it's the user's job to review all the changes, all these changes that have been identified, and mark them as either intended or as unintended. Intended changes are, of course, what we're looking for. And any unintended changes are caused to go back and see what went wrong. Why was something unintentionally changed at this point? Now, this is a really important step for MBD because when your model is such an important part of your manufacturing enterprise, you better make sure that your model is correct, right? I mean, what we found in practice is that our users find unintentional changes creeping into their models on an everyday basis. I mean, this is very, very common. So this is an important check to be making. Yeah, and then finally, as we see here, we have a nice summary report at the end, which shows us the status of our revision comparison. In this case, all of the changes were intended.
Normally, when receiving a revision, the quality planners and metrologists spend hours creating a Delta ISIR report. It's just a ton of work. But using MBD Vidya and QIF, the metrologist can easily process a revised bill of characteristics that shows what has changed, and then issue a revised ISIR form.
Yeah, so the point here is that we've already established that certain characteristics are shown to be intolerance. So this delta step's about fixing the tooling for the non-conformances and then proving that those adjustments to the manufacturing plan are adequately solving the problems. So this is a pretty typical process. But again, I mean, looking at the today's typical 2D drawing based approach for how to do this, this is a very time intensive process. I mean, basically, someone just needs to go through the drawing for each of the two revisions and figure out manually what's changed. But really, I mean, that data, it should exist on the MBD, and you should simply reuse that data. So really, none of that extra work should be necessary. It's all a natural part of an MBD workflow.
Check it out. Only the items we changed are highlighted, saving both the supplier and the OEM time and money. Looking at the measurement results on this revision allow you to examine if there are any nonconformances on any of the changed characteristics on the design. We make it to acceptance. The revised design yields better parts than before, and the product is ready for its full production run. If we combine MBD from 3D CAD platforms, use a standardized approach like QIF, and leverage Capvidia's software tools to enable digital automation of 3D data, then we gain huge savings. I demonstrated how to achieve a 50% time savings and a 50% reduction in manual data reentry. And because we are avoiding the cost of poor quality by reducing the reliance on manual data entry and establishing digital traceability feedback loops between engineering and quality, we hope you will take advantage of increasing the quality of your products using MBD, QIF, and Capvidia's tools to achieve these game-changing benefits. Daniel, do these metrics play out in real life when your technology is used at a company?
Yeah, I would say that these metrics are very realistic. In fact, just recently we had a discussion with one of our very large aerospace customers, and they were talking about how they've done several pilots on using MBD to generate their first article inspection forms. What they were saying is that on average it takes about 8 hours to generate these forms, like kind of with their current set of tools and so forth. But I mean, we're talking about seconds in terms of generation of the form using MBD. And so, they're saying that they have a little bit of, maybe cleanup work or whatever at the end, but we're talking about, 90% savings. Along with the other thing that they pointed out are huge risk reductions. So, and that's just the part of creating the form, and that's just kind of the beginning of the fruits that they'll be able to take advantage of from MBD. So, yeah, I would say these numbers are definitely realistic and probably even a little conservative.
When we integrate the concepts of MBD and digital metrology, we are engaging the core principles of lean manufacturing. These tools and techniques will empower your people to leverage model-based data to enhance the basic principles of PPAP, because this is a continuous improvement method that drives product repeatability. And it improves the understanding of your existing designs so you can improve your future designs. This data gives you valuable and accurate insights to inform your decision making, and it is a better way than documenting your results in a static 150-page handwritten book. Tune in for our next webinar, where we will take the same data and show how it is used in a coordinate measurement machine workflow. See the planning in action, see the measurement results in action. Thank you so much for listening. We'd love to take your questions. We'll go ahead and open up the line.